Okay, so good day once again. So we will be performing our last lab experiment, which we will call as lab experiment number 4 no, today. And you will need no, a composite figure. So it is made of a cardboard. So this is, you can find this at home. You need some metals no, that will try to hold a string. So you have a string here now. And all this no, will be part of our activity in finding the coordinates of the center of gravity. No? So let's try to share a screen. No? Let me share a screen with you. No? And this is, again, no, our experiment number 4, no? Which we call a CG in short, or the center of gravity. No? So the center of gravity, as we've explained in our experiment, in our lecture, no? It's a coordinate, no, which is it contains x and y value, and for every given body, like this one, there's only one point, where the center of gravity is found, and we believe the importance of the center of gravity is that the total weight of the body happens to be concentrated in that point. No? So that's how crucial is the location or determination of the center of gravity. No? Now, among things that we've learned is that we can support or we can balance the body, no? If we are able to identify its center of gravity, by holding it at that particular point. No? So it's easy to balance the body when we determine the CG of the body. No? Now, for our objective, no? So here's our objective. So again, we will determine the center of gravity or the coordinates of the center of gravity of a composite figure. No? So we basically call this as a composite figure. So you will be making your own, no? In your own group, you will be making your own composite figure. And these are the materials that you're going to need. No? So maybe a cardboard, so a piece of uh, stripped out or thrown or discarded cardboard. No? So maybe from a box. No? You can get it. And then you can draw and make your own composite figure there. You need some string, yarn, some push pins, no? So you will need one. And then last is the metallic object. That's just like this one, no? Which is simply used to suspend the string. No? Or if you have a better material, then a heavier one called a slatted weight. No? But we have a picture for this slatted weight if in case you have it in your house. No? But if there's none, no, then you can look for other smaller metallic objects that is considerable in weight. No? They don't have to be big, however. No? Now, for our activity, so the procedure will be shown later. So as again, here is our different materials, the push pin, string, and the other two materials which are our composite figure and our metallic object. Now this one, you can make it out of a certain cardboard. Now the string and the metal is combined together, or it's attached, or the metal is attached on the string. And eventually now you'll notice that if this is now suspended in air, you'll be able to trace a perpendicular line to the ground, from the ground. So this line that is traced from the ground is perpendicular. And if you measure it, or if you place the plumb line side by side with a certain structure like a column, you'll know that the column is either erect or not. If the engineer or the one who built it did not carefully lay it out, you'll notice that you can see, using the plumb line, that it is tilted. So again, that's the purpose of the plumb line, to know a vertical or a perpendicular line from the certain base. Now, in making the composite figure, you can probably cut out a cardboard that is maybe around 8 centimeter. So the top here is 8 centimeter. So if it's divided into 4 squares, then each of this is 2 centimeter long. So 2 times 4 squares is actually 8 centimeter long. And then the vertical side, or the side here on the right, is also another 8. So basically the small squares are 2 cm by 2 cm. So one small square is around 4 square centimeter. No? So if there are 16 of that, then that's a total area of 64. No? So 8 times 8 is 64 centimeter square. No? Now out of this, you are going to cut, no, some sections until eventually, now if you have this, no, you can end up with something like this. No? So you can remove other portions of the square here and maybe, no, something like this. No? So again, no, the way we position this one, no, maybe it's something like this. No? So perhaps it's something like that. No? Something like this. Or sorry, no? So how is that done? So maybe somewhere like this one. No? Maybe something like this. No? Okay, no. Maybe like that. No? So anyway, you have to make your own. No? So if this is the position that your group agreed upon, no? So you can probably draw, no, using your theoretical process, the Cartesian planes already, no? So the x-axis and the y-axis, and you can make this as the agreed upon position. No? So you have to agree, no, on how to place this composite figure. As you will realize, the values of our coordinates will vary, no, depending on how you position this. So the whole group has to decide how to position this figure. No? So granting that this is the position that we will be agreeing upon, no, for this example, then, no, to find the CG of our figure using the experimental method, so you are going to get the pin, no, and getting the pin, you can put it in one corner of our figure. No? So initially, again, this is how you place it. No? And after placing the pin, then somewhere here, now we place the pin somewhere here, and then you'll notice now that the figure will now drop down. No? It will rotate something like counterclockwise. No? Again, if you look at this, so the pin was placed somewhere here, and then it was made to rotate freely, no, until it turns. No? So again, the goal of the pin there is to rotate the figure there so that the figure can freely move. No? So something like this. No? The figure is free to turn, no? As you move it, no, on the pin. No? So after you've made it, no, to move smoothly on the pin, next step is for you to attach the string. No? So you attach the string and the plumb bob. No? So we call the slotted weight below, no, attached to the string as this is the plumb bob. So eventually this line is called as a plumb line. No? So you can trace a line on this plumb line now. No? So using a pencil and maybe a ruler, no, you can mark some ends here and then eventually trace a line on your composite figure, and you can call it as line number 1. No? Now, you will be transferring the pin on another corner. So we will be transferring it. Now, so initially, the pin may be somewhere here. Now we put it on a different corner and then do the same process. Now you let it freely rotate, no, until such time that this figure will just simply rest, no, in its equilibrium position like this. No? So, but again, no, before we did this, no, so uh, we let it rotate freely on the pin again, and we will now next, no, attach the plumb line. No? So you connect the plumb line. So these markings now, if you're going to mark the positions of the string here and trace a line, you will now create another new or second line. No? Now, again, initially there was a previous line made somewhere, something like drawn here, no, on our first position of our plumb line. So this is the second corner already. No? Now, when we return the position of our figure now, having drawn the lines already, by using the pencil, so we will now put back the figure in its original position as we've seen it earlier, agreed by the group. Now we are going to put the Cartesian plane. No? So you will place this now in the x and in the y axis. No? And then therefore, na, since a while ago we've traced two lines, so maybe this is our lines now. No? Maybe one made from this corner and then the other line made at this other corner, no? Using the plumb line. Now you'll realize that they intersect at a single point. No? Now we consider the single point now as the CG of our figure using the experimental process. No? So using the plumb line, we can find actually the location of the center of gravity of the composite figure. No? Now, since we are now on our axis, x and y axis, we can now project a line downward, no? Wherein we can determine, no, approximately what's that value of x. Again, remember, if this whole length was 8 initially, no, so this is 2, this is 4, this is 6, this is 8. So at this particular point, you can estimate how much x will the value be. No? So maybe you can use your ruler if this is exactly placed, no, on the y-axis and this is placed exactly on the x-axis. So you can project a value for x, no, and then record it on our CG value for x. So that's the x coordinate. And likewise, you can also project a line to the left, no, and make it intersect to the y-axis. In the same way, you can also read, no, a value of the y, no, axis. No? So again, you can record it next on the value below. So now we are now able to get an x and y value, which is the coordinate of our CG using the experimental process. No? Okay, so hopefully now that's clear. And now we will be proceeding to the theoretical process. No? So for the theoretical process, we'll be positioning our figure here together with the x and the y axis. No? And then the next thing to do is to divide this composite figure into regularly shaped figure. No? So this is no longer a perfect square, no? Because there are cuts somewhere in between. Now the goal or the rule of finding, no, CG using the theoretical process is first to make it into either squares or rectangles of regular shapes. No? So maybe we can do it like this. We can put lines now and eventually divide this now into 1, 2, 3, 4, 5 figures. No? So having divided that into 5 figures, we can now mark the figures. No? So this whole thing here is figure 1. This is figure 2. This is probably figure 3, figure 4, and figure 5. So figure 1 is 2 by 4. That's 2 centimeter by 4 centimeter. This one is also 2 by 6. This is 2 by 4. This is 2 by 2, which is a square. And figure 5 is 2 by 4 centimeter rectangle. No? So there are 4 rectangles and 1 square. No? Now, again, each of that figure, if this is our example, then we draw our diagonals, no, for each of the figures. So we have all 5 figures, no, and we determine each of their x1 and x2 value. So for figure 1, you'll have x1 and x and y1. For figure 2, you'll have x2, y2. So we make y2 be projected to the left, no? And so on and so forth. No? Now, again, no? Once we've determined all those CGs and all those areas, we now plot it in a table. No? So we now write the equivalent values. So there are 5 figures that we'll be making here. So I only made 3. So in your template, kindly add 2 more figures, no? 4 and 5. And then you can move this total area, no? Somewhere below. No? And again, now calculate the area for each of the figure and likewise write down the corresponding coordinates, no, for x and y for each of the given figure above. No? So again, no, this is not your composite figure. You have to make your own. No? So therefore, this is merely an example. No? Again, no, maybe we can now have the value there and eventually use our formula, no, to find the x bar value. So kindly think, no, that there's a bar at the top there. to give us the x coordinate of the center of gravity of the composite figure. So this is now the coordinates of the composite figure itself. No? So x1 and a1 are for our specific divided, no, or cut portions of the composite figure. No? So there are 5 of this. So this is not a sub n, but until a sub 5. No? So for our example. No? Okay, then a sub t is our total area, which based on our table, no, we can also get it by adding this column on the total area. No? So hopefully you got the idea. And once you solve this value, you can now record, no, the CG value in our table. No? So at the bottom of our theoretical process, you are to write the CG value. No? So therefore, now the process here will be you are going to compare it probably, no, with the previous value we got, no, on our activity here. No? So in this experimental process, there's a CG value, and on the theoretical process, there's also another CG value as well. No? So hopefully, no, you understand the activity. If not, no, then you can go over the video to analyze and understand it. No? But first and foremost, you have to make your own composite figure. No? So thank you and good day. No?